Factoring polynomials. Learning Task 1. Recall your previous lessons about special products among polynomials. Multiply the factors in column A, then match the product to column B. Now let's find out the answers. Number 1, the answer is letter C. For number 2, we have letter A. Number 3, letter D. Number 4 is letter B. And number 5 is letter E. Now let's define factoring. Factoring is an inverse process of multiplication. Through factoring, we write polynomials in simpler form and use it as a way of solving the roots of an equation. Common monomial factor. Let's review how to find the factors of 12. We have 3 times 4, negative 3 times negative 4, 2 times 6, negative 2 times negative 6, negative 1 times negative 12, and we have 1 times 12. Take note, if we're going to multiply like signs, the product is always positive. We have common monomial factor is a process of getting the greatest common factor of each term in the given polynomial. Greatest common factor is the highest number or term that divides exactly into two or more numbers or terms. When factoring in general, greatest common factor will also be the first thing that we should try as it will often simplify the problem. Let's have a refreshing lesson. Do you still remember how to get the GCF of set of numbers? For example, we have set of numbers 6, 12, and 18. As you can see, we have the divisor of 2. And as we divide all the given numbers, we came up with the quotient of 3, 6, and 9. So just repeat, but this time we use the divisor of 3, and we have now the quotients of 1, 2, and 3. So there are no divisor or no common divisor in the remaining quotient. So therefore, we're going to multiply now 2 and 3, which give us the product of 6. And 6 now is the GCF of 6, 12, and 18. Let's do this. Find the GCF of 24, 28, 32, and 36. So this time, we're going to use the divisor of 2 since all the numbers are even. And we have the following quotients that we divided or derived. So we have 12, 14, 16, and 18. Write them below and repeat the step. So we use again the divisor of 2. And the quotients are 6, 7, 8, and 9. Write them down. So we do not have now a common divisor, so we multiply 2 by 2, and we have now 4. And 4 is the GCF of 24, 28, 32, and 36. Today, we will learn about factoring by greatest common monomial factors. To factor a polynomial with common monomial factor, first we have to find the common monomial factor by applying the concept in finding the GCF. Second, divide each of the terms by common factor to get the other factor. And finally, we're going to write the GCF and quotient in the form of GCF quantity of the quotient. For example, we have AC plus BC. We write down the two terms and we're going to find the factors of each terms. AC, the factors are A and C, while BC, we have B and C. So the GCF is C. Now let's proceed to the second step, which we're going to divide each term to the common factor. AC divided by C is A. We have BC divided by C is B. So this time we're going to write this now in the form of GCF and the quantity of quotient. We have now C and the quantity of A plus B. Therefore, the factor of AC plus BC is C quantity of A plus B. For the next example, we have 3x cubed minus 9x squared plus 6x. So let's find out their factors. So the common factor of these terms is 3x. Next step, we're going to divide each term by the derived common factor, which is 3x. And the quotients are x squared, 3x, and 2. Now, we write the final answers. We have to write the GCF, 3x, and the quantity now of x squared minus 3x plus 2. These symbols came from the original equation. Next, we have 8x squared y cubed plus 12xy raised to 4th power minus 20x cubed y squared. This time, we're going to use the continued fraction or continued division, rather. So this time, we're going to use a divisor of 4xy squared and will give us now the quotient of 2xy plus 3y squared minus 5x squared. Take note of the exponents of the variables. We're going to use the smallest exponent of the variables as their common factor, while the numbers, we find the process or we use the process of finding the GCF, which is the greatest factor of 8, 12, 20 is 4. Now, since in the derived quotient have no common divisors or common factors anymore, we're going to write this now as a factor of the given problem. In short, the GCF now is 4xy squared. So the final answer now is 4xy squared and a quantity of 2xy plus 3y squared minus 5x squared. Thank you for watching.